Inverse function. Let's think about what it means to be the inverse of a function. So the way you have to think is what would undo the work of a given function f. For example, if f of x is x cubed, how do we quote unquote undo cubing something? Well, we undo it by taking the cubed root. So its inverse would be the cubed root of x. So for example, let's use an actual value. What's 2 cubed? It's 8. If we want to take the cubed root of 8, we get back 2. What would undo f of x equals 2x? Well, if we take 2 times some value, what's the opposite operation? Well, it's dividing by 2. So the inverse would be x divided by 2. Let's check that with an example. Let's let x equal 3. So 2 times 3 equals 6. Well, what is 6 divided by 2? It's 3, and we got 3 back. And finally, let's look at the linear function x minus 1. What is the opposite of subtracting 1? How do we undo subtracting 1? Well, we add 1. So let's let x be 4 this time. If we took 4 minus 1, we get 3. Well, how do we get 4 back? Well, we add 1 back to the 3, and we get 4 back. So again, that's just kind of a by example way to understand what does it mean to be the inverse of a function. It's like the undoing of the function. So inverse functions, f to the superscript minus 1 of x is read f inverse of x, or the inverse of f of x. So f inverse is the function that will undo the work of f. If we compose a function with its inverse, we will always get x. That was the examples, the actual values I plugged in the table above. We will always get x back if we have the right inverse. So that means if I compose f with its inverse, I will get x. Or the opposite direction, if I compose f inverse with f, I will get back x. What I want to make very clear is this is not f to the minus 1 power. It is not 1 over f of x. So when you see a minus 1 as a superscript in function notation, it is not an exponent. It is read f inverse.